have discussed this first two set of queries in the previous classes, DDL and DML, right? So, so next thing is basically the next set of queries. Maybe query. I'm saying query, not I'm saying clauses, because we will going to start the discussion on the data retrieval queries, right? So when we say the different queries there in the retrieval set, it means it will not be basically based on one single clause or one single operator. Like in the case of DDL, the most of the things has been discussed in DDL and DML are basically depend on one instruction, one clause, right? Like in the DDL, create is there to perform some operation. It is dedicated syntax. It is having dedicated sequence of inputs that you have to mention. Similarly, in the case of DML, if you are using insert, you need to provide the proper parameter, proper statement, set of instruction to perform the task, right? But when we say we are talking about data retrieval queries, so there is naturally six clauses are being used for data retrieval, but for each retrieval, for each basically syntax or each clause for data retrieval, you need to you need to provide the set of database table or set of database attribute to get the desired data value from the database, right? The purpose of this next set of queries are to basically retrieve the data for your need, right? So naturally, when we say the database has been created, tables has been created, now we are trying to operate. You're trying to work upon a database. You wanted to use the data values which has been stored. It is the data retrieval query which will help you to get the required data from the database, right? And that's what we are doing, or we are using the different database system for our purpose, right? So like we are using different databases in our daily routine or daily daily needs actually. And whenever we are searching for something in the stored data, it is the data retrieval query which is getting the data for you, right, from the database or from the data storage, right? So you can understand that for any database, it is the data retrieval query which contributes the most. So like DDL is one time task, DML is probably is a continuous task, but bulk of data has been uploaded in the beginning of the database. Maybe in the future or maybe in the current life, you are adding something onto the database, but it is the data retrieval query which consists of around 95% of queries on a database. So if you consider the database lifetime around 15 to 20 years, 95% queries within this 15 years is of nature retrieval. It is for the retrieval of the data. DDL is there, DML is there, but it is the data retrieval which consists of most of the query set, right? So the purpose of data retrieval is obvious, is to extract, retrieve, identify, or find. So we are using different terms, different nomenclatures uh, in the daily life, like, okay, can you retrieve the data, can you identify the data, can you find my result, something like. So we are using different data, different terms to basically uh, you know hint at a specific retrieval query. So the purpose is to simply identify the specific tuple within the data, right? Eventually, because whenever we are operating on a database system or maybe any information system, we are trying to get a specific tuple, right? So there are three layers of a database. First is database. Within database, we could have multiple database tables. Within multiple tables, there is a specific table which you are interested in. And within a specific database table, you may be interested to get a specific tuple within the attribute, right? So there are these four level of hierarchies which any specific retrieval query will be operating upon, right? So like in the case of DDL, it is the database which you need to create first, then you need to create database table, and within database creation stage, you need to specify the attributes, their data type and their data size, and in some cases it is constrained also. So similarly, whenever we are going to write a data retrieval query, these are the four levels of hierarchy which we need to consider, that how a database control will be looking for the data which is relevant to me, what will be the specific constraints I should be using, right? So eventually, because we will be interested upon a specific set of values, a specific set of tuples, or maybe more than one tuples, maybe more than one rows, and within a specific attribute, or maybe some set of attributes, we could be looking for more than one tuple, something like that, right? So we will discuss upon it. So eventually, it is to extract, retrieve, identify, or find the data values under the attribute, right? Because whenever we are asking for a value, it is naturally coming from a specific attribute. Maybe it is a one single attribute. So if you are looking for your roll number, or maybe you are looking for your result, there must be some attribute named as result stored, from which you are interested to understand or see you only your result. So for that specific attribute, you are interested to understand or see only one specific value, right? So it is the attribute which comes first, and within that attribute, you're looking for a specific value, right? So in some cases, it is for a specific condition also, right? Okay. Now, if you see, when we say values, data values, attributes, it is naturally is attribute. It is basically based on the attributes, right? Which is important. And within attribute, we will be looking for a specific value. That is the hierarchy typically. So, if you see a specific impression of a database instance, there could be a database table which is like having name, date of birth, day number, and within a specific attribute, we could have values, for data of birth, you could have more than one value. For D number, you can have different values, something like that. So this is a typical instance, and basically, you need to see these three hierarchical steps or phases, right? So whenever we are writing, whenever we are trying to understand or identify a data for your interest, the very first thing is to understand or see the possible database table, right? Like within a database we could have multiple database tables. Like if you're looking for the results of yours, you will be going into the college database, right? Within a specific college database, you could see that there is a table named student, then result, then placement, then scholarship, then faculty, then courses. So there could be many databases. So your query, whatever query you are planning to retrieve the data, your query should be identify, your query should have the specific database table. That is the first requirement, right? After spotting the relevant database table, the next obvious step is to identify the attribute where the relevant data value has been placed, right? So you need to identify these two specific things, and you should mention these two things into a specific query which you are trying to identify the data, and you can add many as conditions you want, right? So that's why in the very first step said find the mention attribute on the database table. So mention, or maybe required, you can say required attribute, right, in the database table. Then you can see how to outline or identify the matching values within the attribute. So the values, or maybe you can say tuples also. So let me add tuple. So values always say with a single value within a specific attribute. Now, if you want to add something onto the logical link, that okay, you need to identify the results of all the students of IT1, something like that. So you need to add the logical condition. So the third step is to specify a specific condition, right? But essentially, this is something optional, I can say, because it is coming from a specific need. It is not compulsory for each and every query. But first two steps are kind of compulsory or kind of mandatory, right? So whenever you are writing a data retrieval query, these two steps where you need to specify attribute where the data has been kept, and you need to see the specific tuples where this has been placed, value has been placed. So these two things you need to specify. These two steps are mandatory, right? Other than that, in some cases, it is required to have some logical condition. So this is something optional you can have, right? So typically by keeping these three S steps, there are 6 different clauses has been designed for any data retrieval query, right? So let's see one by one. So there are total 6 clauses has been placed or has been designed or defined for data retrieval query in SQL actually. And out of these 6, first 2 clauses are mandatory, right? So if I say mandatory, it means for each query you have to mention these two. For each query you have to provide the values for these 2 clauses, and there are 4 optional clauses, right? There are 4 optional clauses, and values for these uh, clauses will be required in a specific condition. So suppose you assume that whatever data you are targeting to achieve, it may not be retrieved by using only these first 2 clauses. Then you need to add these additional clauses, right? So you could be having one query where there are 3 clauses, 2 mandatory, 1 optional, right? There could be a query where you need to add 2 mandatory, 2 optional clauses, right? So let's see one by one. So you need to remember this fact that only first 2 clauses are mandatory, right? And you can add the remaining clauses in the query based on your query need, right? So let's see. So there are different these 6 clauses has been designed to perform any data retrieval task. First clause is select, then is the from clause, then where, group by, having, order by, right? So you could have a query for your database need where all the clause has been used. 6 clauses can be used, and if you're using these 6 clauses, this could be the sequence. The very first you need to use select, then from, then where, then group by, having, and order by, right? So naturally these are the clauses. Now you have to see what are the things we have to mention, specify against these clauses, right? So the very first clause is select, which says you need to list down all the possible attributes required in the result. So for a given query you need first name, roll number, and date of birth. I'm not saying specific values. Suppose in a result, in an output, you need to list down 3 4 attributes in the result. So all these attributes should be listed in the select clause. That's clear. Now the next thing is uh, the from clause. So from clause will be having the list of all the tables, all the database tables which will be required to generate the result. It is to list all the database tables for generating the matching value, right? So if you are assuming that to get my needs data for my needs, I need to list down student, department, and courses, because the required result, required attributes are placed on these 3 database tables. So then you need to list down all these 3 database tables onto the from clause, right? So it is quite obvious that these 2 clauses are kind of mandatory, select and from, because from talks about the possible set of tables which will be required to generate the result, and select says you need to list down the attributes whichever are required in the final result. So these two are basically a mandatory kind of situation, right? So let me add here also. Yeah. So next clause is a where clause. Now that's what we are talking about. So in some cases you need to add a additional condition, additional filter, that I need to have only these type of records, these type of results. So if you want to retrieve the results of all the students of IT1 or maybe department number 2, you need to add this condition into the query. So it will be like d number equals to 2, right? After having these 3 clauses, there must be some requirement where you say I need to perform a comparison, I need to apply my condition on a specific set of students, right? So if I say can you perform, or can you find out the age of girls and boys, something like that. So suppose a query required to perform a logical condition on a group, right? So you can, so if a database table is having 20 results or 20 tuples, and out of these 20 you want to perform some comparison or within groups. So like you can create male and female groups within a table and perform a condition, right? So suppose there is a query given to you that, okay, can you give me the number of students for each gender, right? So you cannot write a specific or direct query. It requires the grouping of the tuples in a table, right? So you can create the groups of a database table, tuples groups naturally based on the gender column. So in the database table, if gender is placed as attribute, you can simply create the subgroups or maybe kind of subtables of a student based on this gender column and simply perform the counting, right? So these are kind of situation where we will be asking for group by clause or group by uh, condition. Similarly, if you want to apply additional condition on these group results, which we just discussed, you need to add having, right? So we will discuss all these things, how they could be used, what could be the conditions or different type of condition we can place within each clause. Last clause is basically order by, which is very obvious that if you want to sort the results before publishing the result to the user, you can place this order by clause to arrange the data which has been retrieved, right? Which has been retrieved, you can arrange the data and publish to the user, right? So in a specific query, you could have these 6 clauses where select and from are mandatory, right? And it is typically observed that the order of execution is not from here, not it is not starting from select clause, it is starting from clause. So that's why it is placed, because from clause listed has listed all the database tables which are required in a query. So, I mean, to perform any query, to start the execution of a query, you need to have a database tables. So that's why the execution of a query will start from clause. It goes to where, group by, having, order by, and then select clause at last, right? So you can assume that whenever we do not have these clauses in a query, it is the from clause and then directly select. And if because of some needs, if you are assuming that these query will be having some additional clauses, naturally these clauses will be falling, like it will start from clause, then it goes to where, and maybe this query does not have these three, then it will directly go to the select clause, right? So from clause lists down all the database tables, and if your query now is not having any of these clause, it would directly go to publish the results, right? So this is about order of execution. So typically in a query, if you have more than one clause, it starts from clause and end with the select clause to publish the database results. Now, what is happening internally? So let's partially discuss about it, because it is specifically important whenever you see that how a query can be, how a query will be executing, how it will be generating the results, right? So basically, if you are having all these clauses in a query, so let's assume there is a query which is having all these 6 clauses in a query return. So the this query processor system will basically, so suppose in a query from clause, within a specific from clause only one database table is listed, right? So in a query where we are having these 6 clauses, but in a from clause it is observed that only one database table is being used. So what a query processor will be doing, it will be simply taking out the database table, maybe it's copy, not database table exact copy. So from the backend, it will take out the copy of the database table, entire values, entire tuple, entire attributes, and place it into the temporary storage. So it will become temp1. So it is kind of having a copy of data in the temporary storage. It could be a RAM also, right? So after getting the temp1, naturally a query processor has to go to the where clause now, because this query is having where clause also. So in the where clause, if you have specified a condition called d number is equals to 2, so the system will look for the d number column, d number attribute in the temp1, because temp1 is having the entire database table, all the tuples, all the tuples and all the attributes. So within this attribute set, system will look for the d number column, d number attributes, and then it will apply d number equals to 2. So whatever tuples has been having this d number equals to 2 will be selected, and it will now this all the selected tuples with attributes, all the attributes will be copied into temp2. So temp2, which is again a temporary result, it will be having all the attributes but only selected tuples into the temp2 result. Now, if its system assumes that group by clause is there, so now temp2 will be shared or will be performed group by. Now, after performing group by, you will have what we have said, group by basically creates sub tables. So the table which we have at the temp2 stage, temporary 2 as a operand, it will be decomposed in the background. It will be decomposed into sub tables into the temp3. So temp3 will have more than one table, right? And on these more than one tables, we will have all the attributes. Maybe tuples are lesser. So within temp1, it could have temp31, temp32, right? And within each temp31, 32, we will have lesser number of attributes, lesser number of tuples, but same number of attributes, right? And then we have having clause. So having clause condition will be applied on both subtables in temp3, right? So temp4 also will have more than one database tables. And if you assume that we have to apply order by, so whatever temporary result we have into temp4, this order by clause will be imposed, right? After temp5, if you assume that uh, the database values tuples which has been kept into temp5 has been arranged, then you can go to the select clause. Then query processor will be going to the select clause. There it will simply publish the data for a specific attribute, not for the entire temp file. So again, because in the select clause we have already listed the set of attributes which will be required in the result, so only those specific tuples for specific attributes will be shown to the user, right? So this is how, so for each clause, we will have a temporary result. That's what I wanted to say here, right? So typically, this is how it is happening in the background for each you can say, type of data retrieval query. So one thing is very important here, because each and every operator is having a logical way of operation, like where clause is going to check for a condition on a specific database tuple within a set of attributes. Group by is going to perform the selection and then it is going to decompose the database table. So each and every clause is having some complexity, right? So as a student of computer science, you should have an idea that what could the complexity of select clause with basically with respect to the terms of attributes, terms of tuples in a specific database table, right? So in the different types, different instances, there are various students who has been asked during their interview, campus interview, they are going to be asked, can you tell me the complexity of a group by clause? If we are having a database table where number of attributes are m, number of tuples are n, and there is a attribute which is having two different values, something like that. So each moment you should having clarity that if you are going to impose having clause or group by, what could be the possible complexity of a clause, right? Because they're kind of logical operator. So going beyond, so now let's start taking specific queries, specific clauses for a data retrieval query, right? So the very first obvious query in the data retrieval is to retrieve all the tuples, all the attributes of a specific database table. So this is a very obvious query and you might have already started using these queries. It says if you want to retrieve the entire database table, entire database table, I'm not saying entire database. So it is about select star from students. So star means all means all attributes and all tuple of a specific database table student. So the very first thing is will be executed is from a student. This clause will be executed first, which will take out the copy of the database table student into the temporary storage. And after from, there is no clause mentioned, so it will be directly going to the select clause. And in the select clause, system sees that okay, star has been mentioned by the user. It means user is interested to see all the database tables attribute and all the tuples. So it will simply showcase the temp1 result to the select clause. That's it. Now, if you want to specifically interested on a specific set of attributes, so you can simply mention like select name and DOB and actually from class. So after getting the copy of the student table from the background or from the backup, system sees that in the select clause only these two attributes are required. So it will take out these two attributes from database table temp1 and displays to the user all the tuples listed onto these two attributes. So it could be name and DOB, and these data values could be listed to you. Now, if you want to interested to rename, so there is a specific clause named as a as. So like here we are using name and DOB in the query. Now we want to interest to rename it. So you can simply mention select first name as first name, DOB as date of birth. Now, from the same, so this AS is basically used to rename, and renaming is within the scope of query. It is not renaming. It is not about renaming the database attribute in the database table. It is about only, so the scope of this as a rename operator is well within the query, right? So it will be now shown to the user as first name and date of birth instead of F name and DOB. Tuples will be same, it will not be changed. Now, so this is about renaming. So AS is very important operator. It will be used on only two labels. First is on the select label, which is select clause, and second could be used on the from clause level. There you can rename the database table also, but it should be always within the scope of query. It will not be going to rename the database table's original copy into the database table original copy. It will be simply renaming the attributes or database table name within a query, right? So similarly, if you could see here, like select first name DOB from student as S. So now within a query, this student table name could be referred as S also, right? We will see what is the use of it. So let's take another instance where we are dealing with two database tables. The very first database table is a student with attribute first name, roll number, DOB, and D number. And the second table is basically department, which is having D number and D name. And these two attributes, D number and roll number, are acting as a primary key, and their D number is a foreign key, right? So foreign key referencing to department. Now let's see. So within each database table, we have placed few specific tuples. So in the student, we have first name, roll number, DOB, D number, and we have three tuples placed. Similarly, in the department, we have placed D number and D name. Two tuples has been placed. Now, if you see it carefully, the D number is naturally playing as a foreign key into the student table. Now, if you simply paste a query, and if you are interested, so query could be like, if you are interested to retrieve the students first name, DOB, and D number, right? D number and D name. It could be like this, right? So yeah, so let me simply remove D name. Okay. So if you write this query, select first name, DOB, D number, and it could be like, for this query, it is not required to have department, because D number is already placed well within the query, well within the this table, student table. So you could have first name from here, DOB from here, D number from here, right? So you could have this place. But suppose in the same query, it is requires this to have D name. Right? So in the same query, if it is requested to have the name of the students also, then you have to use department table, right? Now what will happen? So if you mention this thing, let me add here the name and add attribute, add additional attribute in the database table, right? So here you can place a specific value, specific attribute. So for that, you need to mention student as well as department. Now, what will happen? So if you mention these two clauses here, so the select clause is the first thing which will be executed in the query. So in the select from clause, so from clause will list student and department table, and the copy of both table will be taken out from the background, right? So in the temp one, what we'll have in the temp one, because temp one can have only one database table. It cannot have two database table in one storage, temp one. So it will simply create the Cartesian product, right? So Cartesian product will be the simple multiplication of both participating tables, right? So it will be like this. I mean, it will create the simple combination of these three values with these two values, right? So it will be having 3 into 2, which is 6 number of tuples, all the attributes from first table and all the attributes of second table. So this table does not replicate the Cartesian product, but Cartesian product will have these 6 attributes and 6 tuples, because each tuple of first table will be combined with these two tuples of the second database relation. So it will be having, so in the temp one, which is the result of from clause, we will have a Cartesian product which will have combination of values of both participating database tables. So suppose in the from clause we will have more than two database tables. It could be 3, it could be 4 also. So from clause will have the combination, will have the Cartesian product of all the participating database tables. So when we say Cartesian, it means the combination of tuples and all the attributes of participating database tables, right? So there is different problem in this query. So if you write this from the student department, it will simply store the Cartesian product into the temp one. That is very clear. But after this, if you go to the select clause, select first name, DOB, D number, and D name. There is a catch here. System will not able to identify which D number you wanted to fetch, right? Which D number you want to fetch, because D number is kept. So in the temp one here, in the temp one, where we are having the Cartesian product of both student and department, we will have a single database table with six tuples, but and 6 attributes. And in the attributes, we have 2 instances of D number. So in the Cartesian product, we have 2 D numbers, and system will not able to identify which D number you want to identify. Right? This query you can also try it in the system. So whenever we have this kind of situation, uh, there is this clause which we have just discussed as will be helping you, right? So you can simply paste student as S and department as D, something like that. Let me use simple letters, and you can specify like this: S name, first name, S dot DOB, and D dot D number, and D dot D name. Right. So by using this simple clause as, you can provide a temporary name to a specific database table, and you can simply resolve this ambiguity. Now, so if you execute this query which we have just discussed, system will show you that there is ambiguity among the attributes. So which attribute, which D number instance should be picked for the query. So after this resolution, after this statement using as, you will take out basically the specific result required in the database table, right? So the ambiguity has been resolved. Now you will get a specific result for this query, right? So that is for the today's discussion. We will discuss the remaining part of the upcoming topics in the coming lectures in this week.